What up, athletes? Whoop, whoop. All right, let's do this. 10.2. I will use division properties of exponents to simplify expressions. All right, we're going to warm up. We're going to do this warm up. We're going to fully factor and simplify. Fully factor and simplify. What do I mean by that? Well, on this 42 is what? 7 times 6, and 6 is 2 times 3. So I'd write this down as 2 times 3 times 7. That's 42. All over 56, which is what? 8 times 7, or 2 times 2 times 2 times 7. Okay? And I'm doing that so I can see which factors I'm crossing out. So I can cross out a 2, because 2 divided by 2 is 1, so that just becomes a 1, which is why I drew a big 1 through it. 7 divided by 7 is 1, so I can draw a big 1 through it. And I'm really just left with 3 over 2 times 2, which is 3/4. Go ahead and pause it, do that for the rest of these. Ready, set, go. Okay, so looking back at these, all right, what's 30 is 3 times 10, or 2 times 3 times 5. 75 is just 3 times 25, or 3 times 5 times 5. And what do we see here? The 3's cross out, right? And the 5's cross out, and I'm just left with 2/5. This is 36, 6 times 6, and each 6 is 2 times 3, so I'm going to end up with 2 times 2 times 3 times 3. On bottom is 9 times 9, and 9 is 3 times 3, so it's going to be 3 times 3 times 3 times 3. What can I cross out? Well, 3 divided by 3 and 3 divided by 3. And I'm left with up top, 2 times 2 is 4, and 3 times 3 is 9. And last but not least, 54 is what? 6 times 9? Which is 2 times 3, and then 3 times 3 for 9, so 2 times 3 times 3 times 3, all over 144, which is 12 times 12. Each 12 is, let's do this, I'll factor tree this out. So I got 144, 12 times 12, that's 2 times 6, 2 times 6, and that's 2 times 3. 2 times 3. So I'm left with 1, 2, 3, 4 2's. 2 times 2 times 2. And 1, 2, 3's times 3 times 3. So I can cross out 1, 2. But I can cross out 2 3's. And I'm left with 3 over 2 times 2 times 2, or 3/8. I know it's a weird way to solve those, right? Back in the day, you learned those probably 3rd or 4th grade factor trees for least common multiples or greatest common factors. But I'm doing it to demonstrate what you're going to see here in a minute. So we're going to talk about quotient of power. So this time we're looking at the division properties of exponents. Okay, so let's take a look at that. Oh, go down here. Go ahead and write down the words to divide 2 powers with the same base. Subtract the exponents. Probably zoom into that a little bit. Oh, wrong button, sorry. Control. No, not doing it. Oh well. So go ahead and write this down in words. Pause it. All right, I'm just going to move on. I'm assuming you pause it to write it down. Let's get rolling back. Oh, and I did forget to explain it. So in this one right here, just notice, what are we doing? When I have like b to the 12th divided by b to the 9th, that just becomes b to the 12 minus 9, or b to the 3rd power. When I have w to the 6th over w squared, that becomes w to the 6 minus 2. So in other words, same base, we just subtract their exponents, which makes sense. Yesterday, when we had the same base and we were multiplying, we added their exponents, so to divide, we would subtract, right? Okay. Now we can move on with our bad selves. And yours should be filled out, even if mine's not. Let's look at this right here. I'm going to do this once the long way. I want you to write it out with me to show you why it works the way it works. So this is x times x times x times 1, 2, 3, 4, 5, 6, and 7. And then times z all over. And I'm going to space this out appropriately. I have 1x and then times 5y's. 1, 2, 3, 4, 5. Okay? Now notice this is very similar to what we did up top, writing it out, but we did it with numbers so that you could see what happens with letters. Now just like if a number, 2 divided by 2 is 1, 3 divided by 3 is 1, guess what? Any variable divided by itself is still 1. That's why we're going to draw 1 through it. Y divided by y is 1, 1, 1, 1. And 1 times anything is itself, so we can ignore those. And we're just left with nothing in the denominator, and up top we have x times x, which is x squared, and y times y, which is y squared, and times z, so it's just z. So it's x squared, y squared, z. That's the long way. But using our quotient of powers rule right here, let's talk about that. It tells me I can just say, hey, look at this x, it really has a 1 above it. And I have x to the third up top divided by x to the 1, so this is x to the 3 minus 1. Y to the 7th over y to the 5th is y to the 7 minus 5, and then z. And what happens? What's 3 minus 1? It's 2, so x squared. What's 7 minus 5? It's 2, so y squared, and then we're left with z. Same answer. Okay? Why don't you go ahead, pause me, and try to do the next one. All right, let's see how this went. Again, these are just to the 1 power, right? So I'm going to have a to the 2 minus 1, b to the 4 minus 4, and c to the 2 minus 1. So this is going to be a, just a, right, to the first power. And this is going to be b to the 0 power, and then c. I want to talk about this, oh, you can't see that. I want to talk about this 0 power right here. Okay? Anything to the 0 power is 1. What do I mean by that? 3 to the 0 power equals 1. 1.25738 to the 0 power equals 1. Last but certainly not least, 153,675,256,337 to the 0 power. Guess what it equals? 1. Anything to the 0 power is 1. And it makes sense because think about it. What does b to the 4 minus 4 really mean? Well, that's really just b times b times b times b, b to the 4th power, divided by b times b times b times b, which divided by b to the 4th power, which those cross out because b divided by b is 1, 1, 1, 1. What's 1 times anything? It just equals 1. So in this case, that's just going to cross out, equal 1. 1 times anything is itself, so the answer is simply AC. Okay, let me zoom out so you can see all this in case you missed some of it. But anytime you get something to 0 power, just ignore it. It crosses out. It becomes 1. Okay, let's go to our next. Pause this again if you need it. We're going to go to our next slide. Now we're talking about the power of a quotient. So we went from the quotient of powers to the power of quotients of a quotient. So we have a quotient, which is just P divided by Q. That's just a division problem, right? Or, I'm sorry, A divided by B. I was looking at my paper. This is A divided by B. And we're going to raise it to the n power, which means we're going to distribute that and just have A to the m over B to the n. Or if we had 1/4 to the 5th power, that'd be 1 to the 5th over 4 to the 5th. C over D to the 6th is just C to the 6th over D to the 6th. Go ahead and pause it. Make sure this is all written down in your notes. And I'm going to get rolling on. Okay? Let's go back. And here we are. Okay. Now we're going to assume the denominator does not equal 0. Why? Because you can't have division by 0 ever. That breaks math. Take a minute, try to do that. What is it going to become? That's right, just distributes p squared over q squared. Now right here, let's go ahead and do it to the third power. Just did that so nobody could work ahead, right? And that's going to equal what? 3 to the third power, x to the third power, and z. Don't forget the lesson, our last lesson, which says if we have a power to a power, we just multiply it. 4 times 3 is 12. And we're going to divide that by 2 to the third power, and y to the 3 times 3, which is y to the 9th. And let's see, 3 to the third power is 3 times 3 times 3, or 27. X to the third, z to the 12th. All over, 2 to the third is 2 times 2 times 2, which is 8. Y to the 9th. Can any of the variables simplify? Nope, this is y on bottom, x and z on top, so this is our final answer. Nice. Last but not least, let's try a really hard number. You ready? Let's do this to the 10th power. Again, pause this for a second. Go on with your bad self, do it. All right. We just multiply it out, so I'm going to do a to the 4 times 10, which is 40. B to the 2 times 10, which is 20, and c to the 10th. All over a to the 10th, c to the 10th. Now, we're going to switch this to a to the 40 minus 10, right? B to the 20th, nothing's touching the b, and then c to the 10 minus 10. Okay, so a to the 40 minus 10 is a to the 30th power, b to the 20th, nothing's touching that. And then c to the 10 minus 10 is c to the 0, but that just cancels out. And here's my final answer. Awesome. Go forth, do 10.2, crush it. Peace out.